files. Okay. Other than whatever program we are executing or we are running. So whatever data we get, we want to store that data, or we may have some other things where we want to have all the things stored in a file such that later we can check exactly what is the what is the exact timings, or it may be, for instance, now I want to store something that I got a message from UART in microcontroller. Okay, so exactly at what time and what message I got, so I want to just take that and I want to store it in a file. Okay, so that continuously whenever I get messages as well as I want to see date and time, I'll be able to see that. Like we say messages in our phone. So same thing, I want to do it with C program. So at that time what we do is we use something called files. So here we have files, some particular functions related to files. Like we have how to open a file, close a file, then how to write in a file, read in a file. We will see all those things here now. So first of all, what we will do is first we will take how to open a file, how to create a file, and how to read that file. And then we will do writing also. So first of all, when we want to open a file, we will have a function called fopen, file open. Okay, so here we will just write that program first. So these file functions, whatever are related to fopen and fclose, whatever these functions are there, they are all defined in library stdio.h. So we need not have one more extra library. We can simply use this. Now, while opening a file, it will take some arguments. Okay. So what is that argument is that what is the name of the file it has to create and where it has to be created. Or I can say not where exactly, but where we have to give it a name itself, but what will be the argument is what you want to do with that file. Okay, so here we will see that what is with the mode of that file. So I'll say you what exactly modes are there, like read, write, and all these are modes. Functions are fopen, fclose, like that. So first we'll use that. So first we'll go with hash. In this all the functions related to it are there, so we need not write anything separately. Now, what is the syntax for opening a file is, so the keyword here they use is capital file, and then we have to give a pointer where we need to say that what fopen. Why we are using this function is pointer is because we are it will return the exact address, as well as when we give the exact address we will be able to edit that file or read that file. So here we will have to give the name, or we will have the description of this file. I'll simply write some name like C file.c. We are creating file.txt file, so we will have to give this in your double quotes. Comma, and what you want to do with this. So here we will have some command like R. R is for if you want to have only read-only file, you are using R. Okay. If you have something like we will have some commands called W. W is for writing. Then we will have A. A is for append the file. Whatever file is there, already file is there. Now I want to add some data to it. So at that time we will use a command called A. Like that we have some commands and we will just use that commands one by one. So as of now I just want to open a file to write something. So I'll just give like W. That's it. This is my syntax, or you can say this is how we open a file. Okay, so here basically we are not giving only file.txt. Here we will give exactly where you want to have this file. Now I want to have this file on desktop C programs folder. So we need to give the whole particular exactly where you have and everything. We will have to give this exact location of this file where we want to create it. Okay, so what we will do is here we will just open this file as of now, and then we will later we will just change the location exactly where you want to have. Now here first we will have to take a variable f. I am taking fp. Fp is equal to file f open. So now this fp will just point to your file. Okay, so now what we will do is whether this file is created or not, we will see. So here, now, here fp, if it is equal to null, that means 0. Then what it will do is, if we will simply write that like we did with malloc, we will here also we will just write if at all if it is created, fine. If it is not created, file is not created, we will print, and later on we will check. So first we will just print this. Printf file is not created because it is null, which means 0, it is not created. And then we will have one command called exit to what we can say what we can give here is sorry. So here we will use one more function called exit one. Till now we have not used this, but this is one function to terminate our program and say that there was an error for this. Okay, so we will use this function for the first time now. Then we have else. Now in this else we will simply write that file is created. File is created. That's it. And then if at all if it is created, then we will close this file. So for that we are using one function called fclose, and we will give what is the path. Already we have given, we need to give the path. We have not given path yet, so we will give path later. First we will simply execute this program, and then we will exactly give where we want to create this file. Okay, so here what we are doing is simply we are creating a file. So here our file name is file.txt and we want to write something into it. So we are checking that whether this file is created. If this file is created, here it will print simply file is created. If it is null, null is nothing but 0. Now here if this is not created, it will return the value 0 and it will simply print file is not created and it will exit the program. Okay. Otherwise, it will, after creating, it will close the file and it will return 0. So we'll execute this once. GCC. Am I sharing the screen? It may throw error. Why? Because okay, so our error is that here your FP is not declared. Okay, now what is this FP? FP is nothing but pointer. We have not declared a pointer. Directly we are writing into it, right? So FP is a pointer which is pointing to a file. So we need to declare that first. So here we will declare it like file. Our pointer is pointer, file pointer, and we are initializing it to null such that it is null, like null pointer. Okay. We are not pointing because we are not giving anything to this. Later we are declaring the path to a file which your file pointer should point, but initially we are not doing it, and we are not doing anything, or we are not giving any, we are not passing any address to it. That's why we are just initializing it with null. So this is a null pointer. It's starting. And when you write this file, it will be declared as file pointer. Now still we have an error, and that is expected file, expression before file. And the other warnings we have is exit function, implicit declaration of purpose, incompatible declaration, not included or provided declaration, exit. Okay, we have to, this exit is there in stdlib.h, so we will just remove this warning by writing that, including that. Slash include stdlib.h. Now that's it. But other than that, I don't think any other things are. Oh, sorry. Here, while representing your what I was doing is while representing while showing you the syntax, I have just written this file open, f open. Directly we need to give this. This was just a presentation or syntax. So I have not deleted it. That's why we got this error. It's simply f open. That's it. Okay. Because I have done declaration as well as your definition in same file. Now this is executed without any error. So /a.out and file is created. Now we want to check whether this file is created or not. So here we have given the name. What name we have given is file.txt, and you can see here this is file.txt file. File.txt is created. Okay, so simply by using a command called fopen, and why it has created in this folder is because we have not given any path. If we give any path like desktop C programs, or if you give some other folder name, I want to store all the text files in one particular folder. At that time, you need to simply give the path like /desktop/ some folder. That's it. If you give the path, it will be created. Okay, nothing is there in this file. So if we want to open, we can do that also. So we will simply open this file, gedit space file.txt, and nothing is there in this file. Okay, now we will do some operations on this particular file. So already we have used one more function here, which is your fclose, right? So what we are passing in fclose is simply what is the name of your file. Okay. If at all, if already file is opened is nothing but created, and we are ready to do the operations in it. At that time, it will close the file such that there will be no more operations to be done on that particular file, and it will release the memory whatever it has been holding for to write, read, or do some other operations into that file. If at all, if this file is closed, then it will return 0. Okay, or we will have something like we will get one particular error for something called EOF will be there, end of file. If at all, if we have some errors, we will get that error, and the error will be detected. Now we will write something into our file. Already we have opened the file, so now we want to write into this file. Now, even though we are writing into this file, we can't write something like printf. Why? Because this printf will not be working there. So what we will do is we will use fprintf, which is file printf. Whatever we want to print into that file, we will be using fprintf for that. Now, what will be the syntax for this fprintf is what will be the file, and we will directly write that. So here what I'll do is, okay, here you will have, actually you can use fprintf function, and some more functions you can use. Basically, you have to use something which is formatted data. So if you are using something like formatted data, at that time you can use get C, put S, all these functions we can use in this fprintf as well as these things. So shall we write one more program and see? Otherwise I will have to write this program again for you. I'll just copy this program and I'll just open a new file. Now we will write something into this. We have taken a file, then I am taking some integer as well as characters to write something into it. We are taking some cat. We will write some name into it, or we will write something. So here we will write some name, and they are saying how many characters we want to have. We will have some 100, and we are initializing it to 0. Okay, now again we have taken that file and we are opening that file. Next, we will check whether this has been created or not. If file is not created, it will exit the program. If it is created, file is created. Now, after this, we will do the next operation of writing in something into your file. Now, I am taking data of I want to enter the data 2 to 3 times. So that's why we have taken your I. Now I will take something like this. So I'll take my for loop. For I equal to 0, I want to enter the data 2 times. So I less than 2, I plus plus. Here what I'll do is I'll enter the data. What we will use some more functions now. Now here we are not directly giving the data into it. We will use scanf option. So here we will use, as we are using string, we will directly use one function we have not used, and that is getS. So we will use that. So we are using putS to display it. In place of printf, we are using here putS right now. We can use even, because this will not be displayed on your display on your file. So you can use, in place of putS, we can use printf also. Just to see the use of it, we are using putS. Enter this, enter the name, or enter the details, or enter the data, anything you can write. And thereafter here, as we are using putS, we will get getS in place of scanf. We can use here scanf also, but we have not used getS. When you are using here scanf, what we will do is we will pass the address of, right, address of that variable. But when you are using getS, you need not. Here if you have directly an array, you can directly pass where you want to store the data. Okay, we need not give address of name. Address of is nothing but that ampersand symbol we need not give. If it is an array, declared array, then we need to simply pass the name of that. Okay. Now I want to store this data. So here we will be using fprintf. Fprintf. Now, where you want to write that? So my file pointer is this one. Next, what we want to pass? Here we want to pass what we are going to write, the name or whatever we are going to enter the data. Okay. So here what we will do is we will use this %d to display the number dot, and here we will write simply your name, or we will say what data we want to display. So here I don't want to display anything, but in place of name we will write, here we will write name only. So here in place of this name, it will be displaying your data. So %s, because it's a string, \n, comma. Here we need to keep, as we are passing two parameters here, one is number and the other is your string. Okay, so here this I is for number and the string is represented by your name. So here we will write this name. That's it. Here that means how it will print is 1 space whatever data you give. 2 your space. You need not give all these things. If we want, we can give. If we don't want, simply give fp your %s comma name, that will be array name, that will be sufficient. Otherwise we need not give. If you want, we will try that also right now. Now this is our program for using this, opening a file and then we are writing into it. Just to save it and we will compile this program once. Now we have some errors here. Okay, now \n, this we are using it for I think there's no problem with this. File pointer, then we have name. We will do one thing, we'll just erase this. Okay, we have just used this closing, but we have not opened it, and that's why we have got this error. I have used closing braces after \n, but I have not used this or not closing double quotes before it. That's why we got this. See, fprintf is also same. Only the thing is, one argument in printf is increased. Printf takes two arguments. One is what you want to print, and the other one is data for which this percentile D or anything has to be covered, and we have to store that data for what we want to represent that data in that space. Here fprintf take one more argument, that is fp, which is your file pointer. So here it will fprintf will take 3.3 arguments and your printf will take 2 arguments. Now here one more error we have, and that is request for member name in something not a structure or union. Okay, we have not represented it using union, so we have to give comma here. I comma name. Still we have one warning. So the warning is that the getS function is dangerous and should not be used. Okay, fine. Just for seeing, we will just check. Otherwise, we will use scanf only. Now, file is created. Enter the data. So here we will take something like 1. Enter the data. Second enter. I am writing something. That's it. Now, if we open our file, here we can see that gedit, what is that file name? File.txt. We are opening and we can see that 0 name is 1 and the first one name is something. So now we have written our data. We will write it somewhat more properly. We don't want all these data. This. I don't want to print all this. Here we remove all these things and write this name as well as this data. We display only our numbers. And here in place of this, now we will use scanf, and here we will use printf. You can't use this printf function to enter the data into file. Okay, so here we have got one warning. That's fine. No format arguments, we have not passed any ampersand or anything, but that's fine because by default your array is also array will be passing the base address of your base address of your array. It will point to a base address, right? So we need not worry about it. Okay. Okay, so here if we are not writing that, I think we will have to change this, enter the data. Here scanf is not working in this way. Actually it should take. What's this ampersand else? Now enter the data. We have not used percentile s because scanf takes 2 parameters. I have not passed 2 parameters. That's why it has not taken anything. So here we will write embedded, and the other one is embedded programming systems, embedded systems. Now if we open our file, now we should see that already we have data created in our file, right? So whether it has appended data to it or created data once again, or it has created our file once again, we will have to see that. Now I am opening our file, and if you see that here that this file is again created with that same name, so it is not appending our data, but it is simply overwriting this file. Okay. Now, so I think reading and writing is okay. Now we can go for next thing, and that we will use now one more function we will use called put C. Okay. So just now we have used put S. Now we will use put C. What does this put C do is, it will write only a particular character into your file. Till now we were using put S to write a string, but now we will use put C, F put C. Okay. F, whenever you have F printf, F put, all these things, if F is attached before your any keyword, then it represents file functions. So we will use one F put C function now. So I'll just copy that file name and create it again. Copy this whole program. And I'll create one more file. So, now this will be saved. Same thing, if the file is created or not, we will have to check. So we will check that. Now we will just remove this F printf and F closure, this writing option, and then we will write here what you want to do with this. So now I want to print all the characters which are there, like A, B, C, D or something, and I want to put one character there. Okay. Here we will write first. Now I want to have something like, I want to write capital A to Z, so that is represented by your characters by capital A to Z is from 65 to 65 plus 26. I want to display object 90, around 90 characters. Till 90 I will display, and then we will just display this. So I is equal to 65. I is equal to 65. I less than or equal to 90. 65 to 90, it represents your capital A to Z. Okay. And then I plus this. What I want to do is I want to write these characters into my file, but we are not using any strings, but we are using, so here I just comment this one. We are using simply a character by character I want to write, so we are using one function called f put c. Okay, there we were using get s, here we are using f put c, and here what parameters it take is simply what is the character, which is I, and then what is the name of your file, which is your, that's over. Then we will have to close this file. We have already written this function. You are familiar with all these things already?
No.
Because I am going a bit slow, that's why I am asking.
No.
So file is created. File.txt. Now if you see, A to Z is displayed. Okay. So the only difference we have seen here is there we were using strings. Now we are using a character. So that means 26 times this file has been written. We are writing only one character into it. Okay. Now the same thing we will use it for string. In this program only I am writing now. We will use both. So gedit file. Okay, we have created that. Gedit file 2, file 3. File 3.c. Now along with this f put c, we will use even f put s also. So before this we will write this f put s. So what does the what parameters it take is simply whatever you want to write. Like here we were using single character. So here we will use double quotes and what data you want to enter. Okay. So here we will use f put s, and then we will, here we will write embedded programming /n. Here we will have to give your file pointer. So fp is my file pointer. We will just give this file pointer. That's it. Now we are using both the things. One is your file pointer and the other is your sorry, not file pointer, sorry, put s as well as put c. F put s and f put c both at a time.
Okay.
So your file is created. Now here if you see embedded programming, and this is your character. So this is about your f put s and f put c. Okay. Now we have one. Right now what we are using is we are using something like write option. So now we will directly use some function. We have one more function we will use now, and that function is your f write function. Okay. So we will create one more file. So here what we will do is, here we will simply write one thing, and that one is like now I want to create something some data I want to create. I want to enter the data, I want to store the data, but that data has to be given by us, or you can say user defined data. Right now whatever we are writing is writing for our C program, right? So we are writing into it. Now I want to directly write into our file. So we will use some function called fwrite, such that it will write directly into your file. So the syntax we will see now. So here the syntax will be like, first what we need to do is we need to give what is the size of it. Okay, and then we will have fwrite, and then we will have to give the pointer and all directly. Okay, I'll just write it directly. Here what I will do is write here after creating the file, I'll just remove all these things, and now we will write. If the file is created, then what we need to do is we will take one buffer, or we can say one array. Already we have that array called char name. So here this size has to be given, that how many bytes or what is the size you need to give. So here what I am doing is I am giving only 100. If you want, you can give something like max size or minimum size. Okay, so we will change that, but for now we are just giving some 100, and we have given our array name as your name. And then now what we will have to do is we have to use this fwrite and give the name of your array. So we are giving something like name, comma. Here we will give size of what we will have to give here is we will have to give starting range, which is nothing but name of your 0, and then the next will be what is the range of it. So we are giving here maximum range we have given here is 100, comma file pointer. So we will have to pass here 4 parameters. So one is what is the name of your array, second is what is the size of the first base address of your array. Why? Because I don't know here what is there. Here whether it is char, int or anything. Why? Because if we give int and if we try to write a string, then it will be giving something like 8 bytes, 4 bytes. So to just avoid that, here we are giving the second element as the size of the array element, and then we are saying that what is how many characters we have to write, or how many characters memory it has to allocate, and what is the file name. Okay. So, but before that, if we are writing into it, we will have to give something like what we want to write. We have to take the details from your user, right? So we will write something like printf enter data, and then we will use scanf option. So either use scanf or use okay, we will use one more function now, which is fgetS again, which is input function using string. Now here we will have to give 3 parameters. One is the name of your array, second is what is the size of your array, and now you are writing this data directly from keypad, right? So what is the direct input of it? So how you are giving that input? So here we will write std in, which is nothing but standard input. Okay, you are getting input directly from your standard input way. Right now that standard input is nothing but your keyboard. Okay, then we will write, after getting this particular thing from your keyboard, we will simply write this into your file and we will close this. We will check this program now. file. So here we have array undeclared. Oh, but our array name is different, right? Our array name is, while saying array, I just wrote array. Our array name is name. We will have to pass this name here. Name of your array is name. So dot slash out. Now here we will have to enter the data. So we are entering some data. Embedded programming is fun. Now this is created and we will see our text file now. Here this is created, and as we have given 100, what is the size of our array is 100. That's why we got \0. Okay, otherwise we won't get it if we know. So what we can do is, in place of this, I don't know how much memory I'm going to take. So what we can do is we can simply say size. So here we will do that now. We will pass maximum size. That's here we will use one more variable in place of 100. Not variable actually, but one already defined keyword we will use, or already defined name. So here we will use max_size. And if you want to see what is this max_size range, use printf and use something like %d, size of max_size. You will be able to see this. Now wherever we have given 100, we need to change it by max_size. We will have two things. One is max size and the other is minimum size, and these two we will be using in your device drivers as well as RTOS very frequently. Anywhere else we have given here. That's it. Undeclared. So actually max_size has to be declared. Maybe in some other file. No, max size and min size is declared. That means it is not taking it. I'll just check it out what is the problem with it. But for now, again, we will have to go with this. That means again we will have to assign the size. Now we will do one more thing. If at all this is not taking, that means max size is simply a variable like this it is taking. So what we will do is, okay, I'll just define it using hash define. Definitely we will go with max size and min size. I'll show you, but for now I'll just check that out what error I have done there. But for now what I'll do is this, I'll define it in this max underscore. We are writing one preprocessor directive, max underscore size, and here we will give it like 100. That's it. Now this hash define is again a macro. So whenever you are writing this hash define, before compiling, this will be executed in pre-processing stage. When you are compiling a program like GCC, 4 stages will be there. So first stage will be preprocessor. So preprocessing, what it will do is, whatever functions or whatever libraries you are using, it will just copy that whole thing. Now, in place of this max size, everywhere this 100 will be already presented. Okay, already it will just to change, or what I can say is, it will change whatever we have defined here. So max size, in place of max size, everywhere 100 will be written in pre-processing stage before compiling. Thank you. Now also we have, as we have written here 100 characters, so definitely we'll have this \0. So if we give how many characters we want, or actually we will use that max size once again, such that we need not get that \0 again and again. Okay, so this was for your, this we have used fwrite function. Now we will use one more function called fscanf. We have used only scanf, now we will use fscanf. So we'll create one more file again, create file phi.c. So directly the syntax I'll write in this only. We will remove this. We have to see this file is created or not. We have to close this file. So here we will use this as scanf. Okay. So what we have to do is, so we are using here fscanf. Same thing. There it uses, scanf uses 2 parameters. Here fscanf will use 3 parameters. The name of your file. So here we will have %s. %s. And then here the name of our array is name. That's it. So this will ask us to enter the data, and then this is for entering the data. Okay, scanf is used for entering the data. Here fscanf will do the same work, and then here we have to display it. So either use printf or anything. We will use printf or printf, anything, and here we will display it using your name. That's it. Now, if at all, if this is read successfully, we will just use one more printf function to say that this file is read. Okay. So here we will use one more printf function. After closing the file, we will say that we have no need actually. First we will do this only, and then we will edit it. So here we are using fscanf to enter the data now. So here the file is created, but we have not entered any data now. We'll see what does it contain. It does not contain anything. We will have to give this, where we are going to give this. Okay, so here we will have to say, read the data from the file and display it. But for that, we need to enter some data into file first, right? Without entering data, I am trying to read that file. Right now, what we are trying to do is read that data from the file and print it. But we are not writing anything into our file. So we need to write something into our file. So what I'll do is I'll just write some data here in my file. I'll just write some data into my file. So either you write it directly in this, or this time we will do something like this, gedit.txt, and we will write some data here. And that's it. I want to save this, and now we will try to read this file. Now also it's not reading. That means I have done some error in this. So let's find out what is there in this. We have created a file, then we have opened a file. After opening the file, still we are writing. Okay, sorry, I have done some mistake, and that mistake is here we have written W. W is for writing a file and not reading a file. So we have to change it to R, which represents R is for reading a file. Because right now whatever is there, we are simply reading that. So that's why I am writing now. I am changing it to read, and now we will compile it once again. Then also it is not. Let's see once again what is the problem. So here what we are doing is after if we are reading it, and if it is created or not, we are seeing it. Then if we want to use the data, here we are using scanf, we are using, and then we are giving file name, and then here we are giving here array name, and whatever it has been read, we are using test to display that file name. Close here. Here we are not displaying anything in this. I don't think any error is there in this. We are opening the file. The file is created. Scanf fp%is. What is the name of the array? Just a second, I am just rectifying where I have done mistake, because it should read the data. I don't see any error here. File pointer, then file data, which we have given something like name of the array, and then it's using footage, we are reading that file. I can't see any error in this. Have we closed that file? Okay, why it is not reading, I understand. Now, what we are trying to do is we are trying to. Okay. I hope this should work now, but let's see. Now also it will not read. Okay. You're right. So previously we have not saved it, I guess. After writing that embedded, I have not saved it and I closed it, I guess. That's why it is not displaying. So now as we have just written, I have changed the command to read and I have written some data into it. That's why it is displaying now. Okay. So file is created and the data here is this one. So here what we are trying to do is we are using this particular function. First we are writing fscanf is to read the file and then this puts is to print whatever is there in this file. Here you can use even scanf also, printf also. Okay, so fscanf here we have used to simply read what is there in your file. We are not taking any input from your keyboard. We are simply using it to read what is there in your file. Now, what we will do is we will use now the same thing for characters also. I think you can do that. Try to do that. Okay. Read a character. Okay. No. I'll do that. So here what we are going to get is, right now we have used this fscanf. Now we will use this. What is the function? fgetc. Okay. So here we will use this fgetc to print character by character. So same thing we will use. The only thing here we will change is your function. This one. So we will use both, otherwise already what is there in this we will use, and now we will write one more function. So here I don't know how many characters are there in my file. So what I'll do is I'll use one more keyword called EOF. EOF is end of file. So I want to read a character by character till I reach end of file. Okay. So I'll use one while loop because I don't know what is the end of file. So while. Now we are using one character, or we can say I have one integer called I, so I'll take that. So while my I is equal to, or we will take first, we will use this I to get the character. So here what I'll do is I'll just change this I is equal to, here we will take one character which is nothing but right now what I said fgetc. So it will get only one character. From where we are getting this? We are getting this from your file. So we will use this file pointer. So now whatever character we have got from this fgetc, we have stored it in I. Okay. And now we are seeing whether this I, whatever is we have got, is equal to or not equal to end of file. End of file EOF is already defined. So here the EOF will see that whether if this is the last character we are reading. If at all, if it is not equal to end of line, what we are doing is we are simply printing it on our screen. So we are using printf. Printf here we are getting it right. %C. What we have is I. Okay, so we are simply reading it, and we are, if you want here you can just change this int to char also, no problem, because we are reading anyway characters. If you are not writing, then also here I have not written %d but %c, so it will not matter, or else you simply change it. Why to have that confusion also? Okay, so here we are using one function, or else you can use that first you can read the character and then you compare it, there also no problem. What I mean is first get the character F get C F P. If first store that character in I and then check whether this character is UF or not. Okay, both are okay. It will execute till you reach end of line, and what we are doing is we are simply printing it. I hope this is clear. This is to get single character. I hope there is no error in this. So here we have one warning as well as we have one undefined reference to. Okay, I have not written T error. Printf. Typo mistake. Okay, so here this has to be actually displayed 2 times because we are using, one is your character and the other one is fscanf, and then here we have the string, but it is reading it only once. It is not reading twice. So either I don't know where we have to debug it. So for debugging or finding out errors, what I'll do, I'll just simply comment this first because I don't know whether my while loop is working or my fscanf is working. I don't know. Well, my string or character is working, so I'm just commenting it and seeing that whether this is working or that one. So this is working. So I think as it has reached end of line, that's why it is not again displaying the character. That's why it is not displaying again. So once, just to remove this confusion, I'll do one thing. As we are not going to start off the line again, there is nothing to display. Till end of line we are reading that file. Okay, so there is nothing to display by your percentile S, and that's why we are not reading it twice. If we again start it from start, then again it will print it. Okay, I hope this is also clear. So now one more function we will use, and that is your fgetS. So here we have used fgetC, puttest, getS. Here now we will use fgetS. So here in particular, like we have used this fgetC to read one character, now we will read your string directly using fgetS. So same thing, we will just, I'll try to edit in this. So here, I'll remove, okay, I'll just copy this and I will create one more file. I'm just compiling all your programs, so it is taking time. I'll just give you as early as possible. So after creating file and before closing, now we will add this. Now, if my fgetS, so the syntax for this is again same. FgetS takes your 3 parameters or 3 arguments. One is the name of your array, so we are using the name of your array, and what is the size of your array. So our size is 100, comma. Then you have one more character you will take, and that is nothing but argument is your file pointer. And now after getting this, we will see that whether it is equal to null, that means whether it is able to read it or not. If at all, if it is able to, then what we are doing is we are printing. If it is equal to 0 means it is not reading. If at all, if it is reading, then we will use putf. Okay. So here what I'll do is I'll just write if there is, like here we got fp equal to null means file is not created. Similarly, if at all, if it is not able to read, we will just write one printf statement to say that we are not able to read whatever content is there in our file. So error in reading the file. And if we want to simply, if we are not able to read the file, if we want to close, then we will use fclose file pointer and then exit 1 to close the program. And if it is able to read that file after getting the string, then we will use putf or printf, anything in that array name. So here we have putf name. That's it. Successfully we are reading something into our file. Okay. So till now we have used this get now we will read one more function we will use, and that function is read function. Till now we have not used the read function. We have used putf, putc, getS, getC, fgetS, fgetC, fputS, fputc. We have used these many functions. Just to remember, if at all, if it is putc, putS, fputS, fputc, it is same like printf. And if you are, that means simply an output function. And if you are using scanf, fscanf, getS, fgetS, getC, fgetC, all these are input functions. Okay.
Yep.
So here now we are reading one more, we are using one more function, and that function is read function. Till now we have not used it anywhere. So here we will use this read function now. So we are using it in read mode only. Yes, R, fopen R now. Here we have this fread. We can use what is the, how many characters you want to read. Okay, so we will use one thing called fread, and what arguments we can have to pass here is again three. We have to use here four arguments we will have to use here. So first all is the name of our array. Okay, fread name, and then we have to say what is the size. Now if you are using integer, it will just read like after 4 bytes, 4 bytes, 4 bytes. If at all, if it is characters, we will have to say that. Now whatever our data is, we are saying these are all characters, so I am giving size of char. That means 1 byte after 1 byte it will try to read. And how many characters you want to read? We have 100 characters, so I want to read some particular only 10 characters. At that time use this, and then you have this file pointer name. So fread take 4 arguments: the name of your array, size of the character. If you, we will just change it to int and we will see what will happen. So as of now, size of char and 10 characters I want to read from this particular file. After reading, so our data after reading will be there in our name. That means after reading, the data will be stored in the array name. So I'll just use this test to read that array. So our name, that's it, finished. It will be printing it on our screen after reading it. So after reading, the data will be stored in this array, and then I am printing that array. Now, only 10 characters are displayed. If we give this size of array as wrong, then what will happen is, now I am giving size of integer. What it will read? See, here it will read it in this way. Okay, why? Because here he is one character, one byte. If you say char, it is one byte. But when you say int, it will take 4 bytes at a time, or 8 bytes, depending on your size of your integer. Okay, if we assume 4 also, then it will take something like 4 bytes, and that's why we are getting this. That's why we need to give it properly.
Oh.
Okay, so 2 or more functions are left. I'll just use that, and then we will close this session today. So here you have one more function called fseek function. Okay, so here we are using this to, what is the position of your file? We will use this. No, I'll not use this. At that point, should I say you this particular thing? We will try to use this. Okay, now here what it will do is simply it will take fseek. We will see now. Fseek is what is the position of the file. Okay, now I want to enter the data. We will simply first change this data in our file, gedit file.txt, and we will give some meaningful data in this. We will write some meaningful data in this because this is only read-only file. So I'm not, right now I'm not able to, but you can use read and write at a time. Okay. So here I am saying embedded. Yeah. So we are writing one more program now. Oh, sorry, I have not created it, and now I'll remove all these things after creating a file already there. After opening the file, now we will use this fseek option. Now here in fseek we will have again 3 positions available. One is your beginning of the file, and then current position, and then end of the file. 3 positions are available. So we will see what is the new position of indicator. So for that we will have to see right now what is the indicator setting first. Like where is the indicator is at starting position, middle position or end position. We will have to find that. Okay. So what we will do is we will first shift the cursor to that position. First where you want to use that. Okay. After creating we will use one function called fseek, and here we will say that first of all how many parameters it is taking. We will see it will take 3 parameters. One is your foil pointer, and then we will say that here we will shift the position by 1. So here we will say how many by what is the number you want to shift. So here we will use this number offset. We call it as offset, and then here you will say now here when you want to leave the position, you will have to give it using one already defined keywords, and those are seek set, seek current or seek end. That means at starting, current position or end of character or end of file. Okay, as I said, you have 3 things here: seek set, seek current and seek end. Okay, so here we will use this now. Anything we will use. So here if you want to give it at starting, we have to use seek underscore set. If not middle, we will see all the 3, otherwise no problem. So I am giving seek set, and then we will have to read that character. So we are using only one character now. I is equal to f get c from my file pointer, and then we will simply use print. So as we are reading one character, we will use this. Sorry. I. So now we will see what is the output for this seek set, seek current or file a.c. Now here you can see this is the output, which is M. Now we see our file first of all. So here this is our first, we have used 1, right? Seek 1 character, that's why it is displaying 1, because here this is 0, 1 seek set. So that's why it is displaying this. It is displaying properly. Now we will use some other thing to display. File a.c, we will just use this. Seek set, we will change it to seek underscore current, and for that we will have to use this CUR. Then we will see what the output will be. We will try even here. We will use okay. First of all, in place of get as we will use this. Okay, let's see first of all. Output, and then previously we got M. Here also we got M, because right now the position here is M. Now we will try to get here. Here we will write 10. Sorry. Here if you see, here S is nothing but I think 10th position, because I have given 10 in my file. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th position is here S. That's why we got this S. Seek current, and then we will use this seek end. So here from last line there is no character. Here we will change it to some other value. Here we will give 1. Seek end is correct, right? Seek it. So we are giving some character which is not in your CH. Okay. End of file is nothing but your some question mark character. That's why we are getting it. Seek end is nothing but end of file. So we are getting that. So this is how you read you find out your position of your, what is the current position of your character. If you want to use in place of character, if you want to start from zero, and if you want to read those particular characters, use fseek and get string. If you use getS, you will be able to use that particular string. And give in place of I, give the array name. In place of fsc, give get. Okay. If we have two more functions, we have one is rewind function. Now what this rewind function do is, it will, the file position will be set to start. That means if we are writing something at the after, if we have not used one more function called append, we will use that. So if we use this in append, and after that I want to say that I want to go to the beginning of the file. So if you want to add some data to beginning of the file, you will be using this particular rewind function, and then you have one more function called if you have one file and if you want to say that what is the current position of your file, at that time you will be using one more function ftell as well as ftell is the function to tell the current position of your file, and rewind is the function to take it to the beginning position of the file. The example for both we will see tomorrow. Okay. This might be somewhat confusing because without practicing, definitely it will give it. You will not be able to understand this, but still you should have an idea before practicing. If you want it, just now only I'll send you file programs, because we have written all 8 files here, so I will not have to execute it again. But rest of it I will have to give you the file. We will see. Actually this week I am somewhat busy, that's why 2 minutes baby. This week I am just busy for some few days. If at all, if it is possible, I'll give you. Otherwise, I'll give you some programs from internet. That will also be okay, I think. For now, just to practice, I'll give you from program for internet, and then I'll just give you executed programs next week. And one more thing I want to know that if I have some boards, okay. So after this, definitely you have some 2 to 3 topics and small topics left. So maybe by the end of this week, you will be able to finish all the what the advanced programming things also. Like what we are left is with structure padding, then we have bit fields in structures, then we have not written some more programs from MLOP. We have just created memories, but we have not written data or anything into it. So we will have to write programs from for MLOP, CLOP, ReLOP, and free. And then we have left with the structure padding and structure memory alignment and bit fields in structures. Other than that, union is again same, but we'll write 1 or 2 programs for union. And then files are almost over, but we will write some more programs for file also. If at all, if any topics are left, I'll just find it out. Then we have